everyone. So today we're going to be simplifying radicals. We're going to look at the most simple ones today, and then we're going to look at more complicated ones tomorrow. So before we go into how to simplify radicals, first we need to understand what a perfect square is, and then we also need to know what a radical is. So we're going to look at those definitions first. So a perfect square, hopefully this sounds familiar. A perfect square is the product of a number times itself. So here's an example. 5 times 5 is 25. So 25 is considered a perfect square because it's the product of a number, 5, times itself, which is 5. So that's what a perfect square is. And here's a list. All the numbers in bold are perfect squares. So 1 squared is 1, 2 squared is 4, 3 squared is 9. All of these numbers in bold are considered perfect squares. So right underneath each one, you also see that the square root of the perfect square is the number that you multiplied to itself in the first place. So the square root of 1 is 1. The square root of 4 is 2 because 2 times 2 is 4. The square root of 64 is 8 because 8 times 8 is 64. So it's kind of like inverse operations here. But please keep in mind that only the numbers in bold are the ones that we consider perfect squares. So 4 is a perfect square. 5 is not a perfect square. 7 is not a perfect square, but 49 is a perfect square because 7 times 7 is 49. So make sure that you have this list available to you throughout today, tomorrow, and pretty much for this whole unit. So either print it out, write it down. You definitely need this list available to you to make it as easy as possible. All right, so we also need to know what a radical is. So here we have A, and then we have the square root of B, and then we have this little C up here. So this whole symbol here is a radical symbol. In this lesson, and probably in this lesson in algebra, we're going to also call them square roots. The reason being, there's not going to be a number here. So if there's no number in this little C spot, that means that that number is actually 2. So you can call that a square root. So in this lesson, and then basically in all of Algebra 1, it's either going to be called a radical or a square root. Sometimes you'll get to cubed roots where the number here is 3, but for the purpose of today's lesson in this unit, there's not going to be a number here, but the invisible number is 2. So we have our radical symbol. We have the number underneath the radical symbol is called the radicand. The number right in front is a coefficient. And we know if we have a coefficient, this is really saying A times radical B, or the square root of B. And then this little number here is called the index. And like I said, we're not really going to be seeing indexes. All of our indexes in today's lesson and tomorrow's lesson, the index is going to be 2, so it's going to be invisible. But if there is a number there, it's called an index. All right, so we want to simplify radicals. So this radical is not simplified. We want to write it in simplest radical form. So the first thing that we need to do is we need to find the largest perfect square that can evenly be divided into the radicand. So if we're looking at the number 18, what is the largest perfect square that can go into 18, that can be divided into 18? So what I like to do is I like to list out the perfect squares that are smaller than 18. So we had 1, 4, 9, and 16. Then it goes to 25, which is greater than 18, so it obviously can't be divided into it. And I kind of work backwards from there. So I say, okay, can 16 be divided into 18? No, it cannot. 16 cannot be divided evenly into 18, so I know that that's not going to be it. Can 9 be divided into 18 evenly? Yes. We can divide 9 into 18. 9 times 2 is 18. So that is the largest perfect square that can go into 18. So now we're going to break this radical into 2 radicals. One is going to have that perfect square 9, and then one is going to have that non-perfect square 2. And we're always going to write the perfect square first. So I'm going to rewrite this as square root 9 square root 2. So that was the next step after we found that number. So now we're going to just find the square root of 9, which hopefully you remember from that list or just from your general knowledge. The square root of 9 is 3. And then we can't do anything with square root 2. There's no perfect squares other than 1 that can go into 2, so we can't simplify it at all. So you're going to leave it alone just like that. Okay, so it's really important you find a perfect square. Even if it's not the largest perfect square that can go into the radicand, it has to be a perfect square. So I just want to give you an example. We don't want to split this into the square root of 6 and the square root of 3 because neither of these are perfect squares and we can't simplify from there. So we definitely don't want to do that. Okay, so please make sure one of them is a perfect square and then just simplify as you go. You always want to check to see if your numbers under here can be simplified any further. We know 2 can't, so that's it in simplest radical form. So let's take a look at another example. We want to express this in simplest radical form, the square root of 96. So we want to find the largest perfect square that can go into 96. So the first thing that you can do is list perfect squares smaller than 96 on the side somewhere, or just have your list ready. So we have 1, 4, 9, 16, 25, 36, 49, 64, and 81. And then you just work backwards through that list. Can 81 be divided into 96? And if you want, put it in the calculator. 96 divided by 81. Hopefully, using your number sense, you know that that wouldn't work. But if you do get a little confused, that's a really great method to use. 96 divided by 64 is not going to give you a whole number, so nope. 96 divided by 49, not going to give you a whole number. 96 divided by 36, not going to give you a whole number. 96 divided by 25, not going to give you a whole number. 96 divided by 16, now that gives you a whole number. That's the largest perfect square that can go into 96. So what we're going to do is we're going to split it up, where we have radical 16, and then when you divide 96 divided by 16, you get 6. So I'm going to put 6 in that other radical. Now we're going to find the square root of the square root of 16. So what number times itself gives you 16, which is 4. And then we're going to just bring down that radical 6 because we can't do anything with it. We can't simplify it at all. There's no perfect square other than 1 that can go into 6, so we can't go any further. So one example I want to show you is, say you couldn't find the largest perfect square, but you know of a perfect square. So say you knew that 4 goes into 96. Okay, so we can split this up into radical 4 and radical 24. Now the square root of 4 is 2, so I'm going to just bring that down. But we're not done because we can simplify the radical 24. So I recognize, okay, what's a perfect square that can go into 24? 4 can go into 24, and that's 4 times 6. So then you just simplify the 4 again. So the square root of 4 is 2. Make sure you're not putting a square root symbol under that. We do not want to do that because the whole point is to get this out of the perfect square, out of the radical, out of the square root symbol. Okay, so we have 2 and we have 2, and then we have the radical 6 over here. We can multiply these together where we get 4, and then you just bring down that radical 6. So you can use this method if you want to, but you can see that it's an extra step involved. But I know it might not be the easiest thing to find the largest perfect square that can go into your radicand. So either method will work as long as you recognize that you have to simplify this radical over here because it could be simplified. We couldn't do that over here, but we can do that over here. So that's why I prefer this method, because less steps and less places to make mistakes. All right, let's take a look at one more. Expressed in simplest radical form, the square root of 700. All right, so whenever you see a number that is a multiple of 100, I want you to automatically recognize that 100 can be divided into these numbers. So if we had 800, 900, 2500, these are all numbers that can be divided by 100. We have that double zero there. So we know that a large perfect square that can go into this is 100. So I'm not going to write out that whole list like I did before. It would be a pretty long list if I did write it out. So we are just going to go with 100 because I automatically recognized that 700 is a multiple of 100. So what I'm going to do is break it up into 100. And then I know 100 times 7 gives us 700. I'm going to simplify this radical over here. We get 10. And then I'm going to bring down that radical 7 because we can't simplify that. And that's it. So if it has that double zero, remember that it's a multiple of 100. So just to summarize, whenever we're simplifying radicals, we want to find the largest perfect square that can be divided into that number. Break it into two radicals, one with that perfect square. We always want to write that first, and then the non-perfect square second. Simplify your perfect square and bring down your non-perfect square radical. And that's it.